Good morning. Today I will discuss about mechanical vibration. What is mechanical vibration? Mechanical vibration is the actual movement of the machine from one end to other end. So this is the actual movement of the machine from one end to other end about a reference position. For example, you can take this as a part of machine and you can see it is vibrating up and down about a reference position. This is a reference position. It is moving up and down. So in vibration analysis, we can find the condition of machine and we can find what is the fault in the machine. So these are the two main benefits of vibration analysis. And also we can make balancing by means of vibration analyzer. So let us discuss about some basic things about vibration. So what is mechanical vibration? What is mechanical vibration? It is the movement of the machine from one end to other end, again and again, about a reference position. Movement of machine from one end to other end about a reference position. When there is a mechanical vibration, there are two things which are very important. One is frequency. How many times vibrations happen in 1 minute? How many vibrations are there in 1 minute? And the second thing is amplitude, which means amount of vibration. So, as I told you that vibration analysis, the benefits of vibration analysis okay. So benefits of vibration analysis. We find condition of machine, and second is we find fault in machine, and number 3 we can make balancing. Okay, so how we do these 3 things, how we can find condition of machine, how we can find the fault in the machine, and how we can make balancing in the machine. For that we must understand some basic terminology, some basic concepts in vibration analysis. First thing is, what is mechanical vibration? So that means the actual movement of the machine, and when the machine is moving up and down, this is called mechanical vibration. Movement of machine from one end to other end, from one end to other end. Movement of machine about a reference position, about a so movement of machine from one end to other end about a reference position. This is called mechanical vibration. Now when this machine is moving up and then it comes down and then it comes back to same position, this is called one vibration. One vibration. What is one vibration? Movement of machine from rest position So what is one vibration? Movement of machine from rest position to up to you can say from rest position to one end and then it comes back, it comes down to lower end or other end, and then coming back to, and then coming back to rest position. So one vibration means movement of machine from rest position. This is the rest position. It go up and then it go down and then it comes back to the same position. This is called one vibration. This is the reference position. It go up, it come down, and then it come back to same position. So this is one vibration. And the number of vibrations in 1 minute or in 1 second is called frequency of vibration. Now, one vibration is represented by this curve, as you can see here, and the total number of vibrations in 1 second or in 1 minute will be called frequency. Like this is, it go up, it go down, then it come back to same position. This is called one vibration. So, number of vibrations in 1 second or in 1 minute is called frequency. And we denote it by cycle per minute. Cycle per minute. Okay, I will write again here. What is frequency? And so frequency means number of vibrations in 1 second or 1 minute. Normally vibration is taken per minute because machine speeds are in minute, revolution per minute. So for comparison of frequency with RPM, it is good that frequency should be also in cycle per minute. Cycle per minute means vibrations, how many vibrations in 1 minute. So CPM, it means how many vibrations in 1 minute. Cycles means vibrations. Vibrations. So, frequency of vibration means number of vibrations in 1 minute. Now the second most important thing is called amplitude. Amplitude means amount of vibration. Amplitude means amount of So amplitude means amount of vibration. Now when you are going to market, or if you want to purchase some things, there are three different ways to tell that something is more or less. How you can tell that something is more or less amount of anything? That is by weight, by number, and by size. In the similar way, if we want to tell that vibration is more or less, we have got three things. We have got three characteristics of vibration which can be used to tell that vibration is more or less. This was for more or less. This was for ordinary things. For example, you want to buy apples. You need 1 kilogram, 2 kilogram. How many apples you want, you can tell by numbers or by size also. But in case of vibration, you can tell that vibration is more or less by displacement. What does it mean? What is the meaning of displacement? In case of vibration, when it is moving, you can see that it is moving from one end to other end. In this case, if it starts from here, it go here, and then it comes back here, and then it comes back here. What is the peak to peak distance? This is the peak to peak distance. It go from here to here, then it come back at the lower position, and then it come back to same resting position. This is called peak to peak displacement. Peak to peak displacement. So this is called peak to peak displacement. How much the distance the machine is moving from one end to other end. So this is one thing we can tell by displacement, that vibration is more or less. What is the second thing? Now you can see that when this machine is moving up and down, its velocity is changing. Its velocity is changing. Velocity means speed in a given direction. So its velocity is changing. You can see the velocity. You see that there is a velocity of this machine when it is moving up and down. At this point, the velocity is maximum, and here the velocity is 0. So we can also tell by means of velocity that vibration is more or less. And we take V peak velocity. means maximum velocity. Peak velocity to tell the amount of vibration. And as you know that velocity depends upon two things. One is displacement and the other thing is frequency. It is very simple to understand why velocity depends upon displacement and frequency. If somebody is making 1000 meters, okay, if somebody is running and he covered the area of 1000 meter means 1 kilometer in half hour, and the other one complete 1 kilometer in 1 hour. So it means that the speed of the person who's making 1 kilometer in 1 hour will be more. Will not be more, it will be less. So the person who is making 1 kilometer in 1 hour, the speed will be less. And the person who is making 1 kilometer in half hour, the speed is more than the person who is making 1 kilometer in 1 hour. So if the same time is taken for to travel in same time, now this here in this case 1 kilometer is traveled in half hour and here 1 kilometer in 1 hour. So the person who is making 1 kilometer in half hour, his speed will be more. So that's why we can say that velocity depends upon displacement. Velocity depends upon displacement. So velocity depends upon displacement. More the displacement, the more will be velocity. Okay. Now what is the second thing? Frequency. Frequency means how many vibrations in 1 second or in 1 minute. Okay. Now we come to second point. For example, if a person is making 10 trips in 5 hours, and each trip is 1 kilometer. Each trip 1 kilometer. Trip means he go to some position, some place, and he comes back. The another man makes 20 trips in 5 hours. So the one who is making 20 trips is having higher speed. This person must have high speed, more speed than this man, because he is making 10 trips in 5 hours and he is making 20 trips in 5 hours. So this man who is making 10 trips in 5 hours, his speed will be less. And the speed of the person who is making 20 trips in 5 hours, his speed will be more because he is making more trips. 20 trips here and 10 trips here in same time. So same thing is here. If the number of vibrations are more, number of trips, vibration means go up and come down. Go up, go down and then come back to same position. I will say this is trip or vibration. So if there are more vibrations in 1 minute, the frequency will be more. The frequency will be more. The number of vibrations per minute increases, it means the frequency increases. So, if the number of trips are more, it means the speed will be more, the velocity will be more. If the displacement is more, it means the velocity will be more. When we say the frequency is more, we means number of vibrations per minute. So this was about displacement and velocity. So displacement simply tells you how much is the machine moving from one end to other end. And the machine will break up when something is bending too much, when something is bending too much. So in case of low speed machines, not more than 700 RPM, the machine will break up in case of high displacement. So let me
see.
Okay, I will come. You want something?
Yeah, both the machines are being used.
No. I have one machine only. I am just making video.
Yeah.
Just after half hour you can come.
Yeah.
Okay. Okay, my friends. So I was discussing about amount of vibration, and amount of vibration, as I told you, we find by displacement and so amount of vibration we find by displacement and velocity. Amount of vibration and amount of vibration is called amplitude. So as I was telling you that displacement means how much the machine is being bent. So if it is bended more, it will break. And this can happen so for slow speed machines, it will break only when it has got high displacement. You can say up to 800 RPM. And displacement tells about bending effect, and stress. Stress means how much force is acting. You can simply say how much force is acting. Now the second thing is velocity. Velocity depends upon two things. One is displacement and the second thing is frequency. So when we talk of velocity, it is telling us that how much is the distance the machine is moving, how much the distance the machine is moving. And the second thing is how many times it is moving, how many times it is going up and down. And this is a common observation in our life that when we want to break something, we will bend something again and again and it will break. If we don't have a tool, we will try to bend something again and again and it will break. And the machine will break if we bend it too much or if we bend it too often, many times in 1 minute, more often. So this is this phenomena in which we are experiencing two things. One is how much bending, and how often I am bending something is called frequency. How much bending, this is displacement, and how often I am bending something, that is frequency. So when we talk about velocity, we are taking care of two things: how much the machine is moving and how many times it is bending, which is called frequency. So most of the time velocity is a good indicator to find condition of machine, So velocity is good indicator to velocity is good indicator to find condition of so velocity is a good indicator to find condition of machine, and most often in the plant we are using velocity to find condition of machine, and in this case you can see here this is a vibration analyzer. Now here you can see in this figure, this is a vibration analyzer, and this is a weight machine which is used for balancing. So this vibration analyzer tells us about frequency, and it tells us about amplitude of vibration. So this is the instrument which is telling us frequency and amplitude of vibration. Okay, coming back to amount of vibration, there is one more characteristic of vibration which tells you about condition of machine. What is that? That I am going to discuss. So velocity is used to find condition of machine So velocity is used to find condition of machine. And you can see here, this is a sensor, and this is used to measure the amount of vibration. this sensor measures the voltage, and this end goes to the vibration, and this end go to the vibration. This end goes to the vibration analyzer, and this sensor is attached to the machine, and it can tell you about displacement and velocity. This is accelerometer. It has got inside crystal. So when that crystal is pressed, it will create voltage, and from that voltage we can measure the acceleration, and from acceleration we can find the velocity and displacement. So now we will discuss another thing, which is called acceleration. And that also tells you about amount of vibration. So what is acceleration? Acceleration is rate of change of velocity. Now when this machine is moving up and down, its velocity is changing. Here its velocity is 0, and here its velocity is maximum. So, but in case of acceleration, acceleration is maximum here, and acceleration is is 0 here at this point. At this point, again acceleration is maximum. Now acceleration is change of velocity. Acceleration is change of velocity. For example, if you are going to the Dammam and you start the car at 0, and after 1 second your speed is 5 meters per second, and then after second your speed is 10 meters per second, and then after third second your speed is 15 meters per second. So it means every second your speed is changing by 5 meters per second. Again you start the car, and after 1 second your speed is 5 meters per second. After second your speed is 10 meters per second. After third second, your speed is 15 meter per second, and after fourth second, your speed is 20 meter per second. So it means that your speed is changing by 5 meter per second, and this is called acceleration, and this is called acceleration change of speed, or rate of change of speed. Now you must have studied some basic equation. Force is equal to mass into acceleration. If there is more acceleration, then there is more force. If there is more mass, then there is more force. So acceleration in the machine tells you about force in the machine, and this also tells you about amount of vibration in the machine, which is called amplitude of vibration. And acceleration is good to measure where there is a very high speed or high speed machine components like ball bearings, gears, etc. So acceleration is good for fine condition of gears or ball bearing. So those components of machine which have got high frequency, you can measure by velocity or acceleration. So all these three things, displacement, velocity and acceleration, tells you about condition of machine. Okay, now I will discuss about spectrum and time waveform. What is spectrum and what is time waveform? So spectrum and waveform you can measure from vibration analyzer. So number one is waveform, number two is spectrum. So we are going to discuss these two things, waveform and spectrum. Waveform is like a graph, and it tells you how the amplitude of vibration is changing with respect of time. This side is a time and this side is a amplitude. So this variation of vibration amplitude with reference of time is called waveform. And this is one vibration. This is one vibration. These are two vibrations, and this is three vibrations. So this is two vibrations, and this from here to here is three vibrations. From here to here is three vibrations, and from here to here is one vibration. And the time taken for one vibration is called time period. And it is denoted by capital T. So time for one vibration is called time period. For example, one vibration takes 0.025 seconds. So this will be called time period. This will be called time period, and frequency will be equal to 1 over T. Frequency will be equal to 1 over T. So in this case, 1 divided by 0.025 will be the frequency per second. So let me find what is the answer. The answer is 40 cycle per second. Now if you want to find number of vibration in 1 minute, which means cycle per minute, then you will multiply 40 by 60, and this will be equal to 2400 cycle per minute. 2400 cycle per minute. So 2400 cycle per minute is frequency per minute, and 40 was cycle per second, and the time for one vibration was 0.025 seconds. So this is how I can get vibration from this formula, cycle per second. And for cycle per minute, I will multiply by 60, because there are 60 seconds in 1 minute. Okay. So that's okay. Now what is the second thing? Spectrum. Spectrum is a graph between frequency and amplitude. Spectrum is a graph between amplitude and frequency. For example, if you get one line here, and this is amplitude in velocity, and this is, so it means the frequency is 2000 cycle per minute and amplitude is 1, 2, 3, 4, 5, 6, 7 millimeter per second, because this amplitude is in velocity. So amplitude you can select in displacement or by velocity or by acceleration. So by vibration analyzer, by vibration analyzer, you can find the spectrum and you can find the spectrum with displacement and frequency, or with velocity and frequency, or with acceleration and frequency. Now I will show you the spectrum here, and you can see it here. Okay, you can see here, this is a spectrum. On this side is frequency and on this side is amplitude, and amplitude is in microns and the system is metric. This you can see here, this is a peak here, and you can also see waveform. Okay. Now you can see here, this is a waveform. This side is time and this side is amplitude in displacement, microns. So you can now understand what is spectrum and what is waveform. waveform is a graph between amplitude and time, and spectrum is a graph between amplitude and frequency. Okay, now let us discuss about the benefit of frequency and benefit of amplitude in vibration analysis. Okay, so now we will discuss about benefits of or uses of measuring amplitude and frequency. Okay, so amplitude, which is displacement velocity and acceleration, tells you about condition of machine. It tells about condition of machine. Same like when you go to the dispensary or hospital, they will take your temperature and they will also take the reading of your blood pressure to find out what is your condition. Is your condition is okay or very bad or still or serious. So, but in case of machinery, amplitude tells about condition of machine, which is displacement, velocity and acceleration. This we have already discussed, that what is displacement and what is velocity and what is acceleration. And for measuring these things, we have got two systems of measurement in vibration analyzer. One is metric system and other is English system. We will discuss in detail again about these two systems, metric system and English system, and what are the units of displacement, velocity and acceleration. So now amplitude tells about condition of machine, and the second thing is fault in the machine. How we can know about fault in the machine? That is by frequency of vibration. Frequency of vibration which is we measure by cycle per minute tells about what is the fault in machine. Frequency of vibration tells about fault in machine. You can take an example of a doctor, that when doctor want to know what is the sickness in case of human being, he will make X-ray check, blood check or some other check to find out what is the problem. But in case of machine, by knowing the frequency of vibration and also relating it to RPM, we will find also RPM of the machine, and we will find the relation of frequency with RPM of machine relation of frequency with RPM of machine. So by knowing the relation of frequency with RPM of machine, we can find out what is the problem in the machine. For example, if the frequency of vibration is same as RPM, we say one time, which means one time RPM. For example, if RPM is 1753 and frequency is also 1753 cycle per minute, I will say frequency is equal to one time RPM, which is 1753. So in case, for example, the frequency of vibration is same as RPM, it means that the problem is unbalanced. If I will see the frequency one time, two time and three time, I see three vibrations and they have frequency one time RPM, two time RPM and three time RPM, it means the problem is misalignment. Now in this case, the problem is unbalanced, and in case I get frequency one time, two time, three time, what does it means? I get 1753, I get 1753 multiplied by 2, I get 1753 multiplied by 3, whatever is the answer, it will tell me that the problem is misalignment. Okay, now the question is that why frequency give indication of the fault in the machine? The reason is that when there is a fault in the machine, they create some forces or energy cycle. and from these forces which happen in the machine one time, two times, three times, we get an indication of the type of problem. For example, if there is unbalance, then there is a one peak of energy once in one revolution. So number of peaks of energy will be same as RPM of the machine. So I will know that the problem is unbalanced. Now in case of this fan, it has got 4 blades. It has got 4 blades, these blades, okay? And in this case, the 4 blades will touch this cover plate every revolution. So there will be 4 peaks of energy in every revolution, which means 4 vibrations in every revolution. So if the speed is 1000 RPM, the number of vibrations will be 4000 cycle per minute, because in one revolutions there are 4 vibrations, because there are 4 blades of the fan, and each revolution the 4 blades are touching this plate, and the amplitude which I will see at this frequency, the frequency is 4 times RPM, which is 4000 cycle per minute. The amplitude at 4000 cycle per minute will tell me how much the blades are touching. Now if I touch this one, now the blades are touching more than before. There is more friction, and I will get more amplitude. I will get more amplitude at the same frequency, which is 4000. So the amplitude gives me an indication how severely the blades are touching the casing or this cover plates. If they are touching too much, so the amplitude will increase. At which frequency? 4 times the fan, 4 times the RPM of the fan, 4 times the RPM of the fan. So the amplitude will increase at 4000 cycle per minute when the blades are touching more severely. And what is 4000 cycle per minute? This is the blade has got, the fan has got 4 blades and RPM is 1000. So 4 blades multiplied by RPM. RPM is 1000. So answer will be 4000 cycle per minute. So I will again repeat. I have given you the example of this fan. It has got 4 blades and its RPM is 1000. And in each revolution the four blades will touch 4 times. So we have a fan and it has got 4 blades and RPM is 1000. So in one revolution, the 4 blades, in case they are touching this plate, there will be 4 vibrations. And in 1000 revolutions, the number of vibration will be 1000 multiplied by 4 is equal to 4000 cycle per minute. So by knowing the frequency of vibration, by knowing the frequency of vibration, RPM of machine and the fan blades, number of fan blades, you can say number of fan blades I can get an idea what is the problem in the machine. So frequency help us to find the fault in the machine. But to find the fault in the machine, we should know the RPM, we should take the measurement for frequency, and we should know what is inside the machine, what are the parts inside the machine and what is their construction. For example, I must know that there is a fan in this machine and it has got 4 blades. So, and I should know that in case the fan blades are touching the casing, there will be frequency of 4000 cycle per minute. And of course, because these are impacts, I will get many harmonics of 4000 cycle per minute. And this happens in case of impacts. Impacts means when something hit something. Harmonics means multiples. I may get multiples of 4000 multiplied by 2, 4000 multiplied by 3. So these will be the multiples or harmonics of 4000. So it means, I will again summarize or review now what we have read and what is the main benefits of vibration analysis. So vibration analysis help us to find condition of machine, and this is by amplitude. which is amount of vibration. This is also, and this is called, this is amount of vibration. The second thing is, we can find fault in machine, and this we can find by frequency of vibration, RPM, and geometry of parts inside machine. Which means, what are the parts inside the machine and what is their construction. For example, if we want to find that the belt is damaged or no or not, we want to see that if the belt is damaged and how much it is damaged, we will calculate first the belt frequency. Belt frequency means how many times the complete belt passes on any point. And again, we have to calculate this belt frequency by knowing the belt length, RPM of the machine, and diameter of the pulleys. One is driven and one is a driver pulley. And again, in case of ball bearings or rolling bearings, we can find the frequencies which will tell us about the problem in the bearing. These are called defect frequencies. And in the bearing, this can be different faults. It can be ball damage. For example, this is a ball bearing. It has got 4 parts. This is inner race. There are balls inside. There is a cage which is holding the balls, and this is a outer race. Now there can be any defect in all 4 components. Maybe the inner race is damaged, maybe the ball is damaged, maybe the outer race is damaged. So first we will calculate the defect frequencies by knowing the number of balls, by knowing the speed, by knowing the diameter of the ball and pitch diameter of the bearing. So from all these things we can calculate the defect frequencies of different parts here, like ball pass, inner race frequency, ball pass, outer race frequency, ball spin frequency, and fundamental train frequency. This is the cage frequency. Ball spin frequency is the frequency which will tell me if the ball is damaged or not. Ball pass frequency, inner race, will tell me if in case inner race is damaged. Ball pass outer race will tell me in case outer race is damaged. So by knowing the machinery part and its geometry, I can calculate the defect frequency. And if I see same defect frequency in the vibration analyzer, it tells me that there is a problem with this part. And the amplitude at that defect frequency will tell me how much is the problem, how serious is the problem. Like in case of fan blades, if the fan blades are touching more, the amplitude will increase. Like here. Now when I press this one, the amplitude will increase. Now it is touching little. The blades are striking the plate slightly, so the amplitude will be less. But now the amplitude will increase at the same frequency because blades are touching more. So this was all about some fundamental concepts of vibration analysis, and what we discussed today is that what is mechanical vibration, what is amplitude, what is frequency, what is time period, and how amplitude of vibration can help us to find the condition of machine. We discussed that displacement is good to know the condition of machine in case of slow running machines up to 800 RPM. It tells us about bending effect, how much the machine is bending, and in case of slow running machine, the machine will break only when there is a more displacement, because here it is more important how much I bend. Here it is not important how many times I am bending it, because I know the frequency is very small. So the only way it can break is that it will bend too much in case of slow speed machines running. But in case of normal machine running and high speed machine running, the machine will break up due to two reasons: how much it is bending and how many times it is bending. How much it is bending is displacement, and how often it is bending is frequency. So thank you very much. That was all about basic concepts of vibration analysis.